So today we're going to talk about circles, and we're going to start with basic terms for these circles and spheres and so forth. So first of all, we're going to define circles for you. Here's the definition. It says circle is set of points. So just like segments and lines, guess what circle is made up of? Points. But unlike segments or lines, these set of points, they are in plane at a given distance from given point in that plane is what a circle is. Okay. So at first you may go, okay, what does that really mean? But think about this. Circle is set of points in a plane at a given distance from a given point. So you fix a given point, and you look at all the points that has a given distance from that point. So for example, look at this Ferris wheel. You see the center of this Ferris wheel? Okay, let's say, look at every point on this circle, right? Look, what do you notice about the distance from the center to every point on this circle? It's fixed. It's 10 units, whatever this unit might be, right? So that's how we define a circle. Does that make sense? So these are set of points, as it says, in a plane. Why do you think they put that in? What would happen if they left that out? If they just said set of points with a given distance from given point, what would you get? Two people see it? Okay, what do you think, Hannah? Yeah, it's going to be 3D, so what would you get? You would get a sphere. Does that make sense? So as you learn in a minute or so, it turns out that that's how you define a sphere. Okay, so instead of on a plane, if you're talking about in a space, right? These are several points that have a given distance from the center. You get a sphere. Okay. Any question here so far? Okay. All right. Then take a look at that given point. Now has a name. Guess what the given point is called? Like that center of the circle. Guess what it's called? The center. Okay, it's sort of obvious. Yeah, so write that down. That's when we talk about that given point, we mean the center of a circle. That's how we define that. Okay, pretty obvious. And take a look at this, and of course you all know what a radius is, right? And the given distance is the radius. Okay, and also you could talk about radius as a segment joining the center to the point of a circle. Okay, it's also called the radius. So sometimes we refer to radius as the distance from center to the circle or the segment. Okay, so you will know which one we're talking about. But so in that paragraph, there's a whole bunch of terms that you need to know, right? Circle, center of a circle, radius, and so forth. Okay. Any question though? This is pretty straightforward, isn't that right? I bet a lot of you already knew, right? What a radius is, what a center of a circle is, right? I don't know how many people knew that circle is a bunch of set of points. Okay. If you didn't, now you know. Okay. This is how we define circle. Okay. All right. So who could tell me something about the radii of a circle? Radii, of course, is the plural of radius, right? Radii of a circle is, what do you think? Always? Radii of a one circle is always? Yeah. Congruent. Yeah. Very good. Okay, so as you can see in this picture, the rim of this Ferris wheel with the center O has a radius of 10, and as you can see, all the radii will be 10 units. Okay, so that's pretty straightforward. All right, may I move on? Okay. Yeah, so this is, you know how we have symbol for like congruent, parallel, perpendicular? Yeah, we have a symbol for circle. So this is symbol for circle, and then yes, we named the circle with that center of whatever that point is called. This time it was called O, so this is circle with center O. You're right. Okay. Mm-hmm. Okay. All right. So there's something called, when we talk about circles, I don't know if you guys heard of this before. Chord. I don't mean like piano chord or guitar chord, like C sharp minor. You know, I don't. In a circle, what do you think a chord is? How many people have heard of chord? Circle. Okay, so not many of you. What do you think it is? Jason, do you remember what it was? You're exactly right. So here's a picture of it, and you see the chord on top. It's basically a line segment whose endpoints lie on a circle. Okay, so that's what a chord of a circle is. It's a line segment, okay, whose endpoints lie on a circle. So there's a picture. Chord. What do you think if I were to extend this chord? In other words, if I were to draw a line on top of this chord, what do you think that line is called then? Because if it says chord is a line segment, right? Because it has two endpoints. What do you think if I were to draw a line on top of that chord? It is called? Oh, you know, what do you think? A secant is correct. So that's right. Yeah, I know. So that's what a secant is. The secant is nothing more than a line that contains a chord. Okay. So do you see the difference between chord? Oh, actually, let me show you the picture, whole thing here. So there's a chord, and there down here you have the secant. So secant is nothing more than a line that contains a chord. Okay. So chord is a line segment where the endpoints are on the circle. Secant is a line that contains a chord. And diameter, okay, as you can see, I read a lot of you know, diameter is a chord also, but it's a special type of a chord because it's are all the chords diameters? No, the diameter is a special kind of chord. Anybody know how special this is? It's a chord that happens to, yes, Nico?
It contains the center.
Exactly right. It's a chord that contains the center of a circle. Okay, so as you can see in this picture, do you guys see the difference? The reason why we have to go through all these terms is because in this chapter we're going to talk about a lot about circles, and if you don't know these terms, when we describe something like in a theorem and things like that, if you don't understand what we mean, you know, if you don't have a good knowledge of these terms, then you may misunderstand, and that would not be a good thing. So that's why we're going through these terms here, so that you know exactly what we mean when we say chord, secant, diameter, and so forth. Okay? Are all diameters then a chord? Yes. Are all chords then? Are they diameter? No. Okay. What about secant? Is secant a chord?
No.
No.
Yes.
No.
Secant is not a chord. It contains a chord. Okay, so be careful. All right. Does that make sense? Okay. May I move on? Anybody need more time? Seems like most of you are done. Yeah. All right. Then next thing I'm going to talk about is tangent. Now, you may say, wait a minute, tangent. We learned tangent before, right? But that was for a right triangle, right? When we talk about the ratio of a right triangle opposite of adjacent, that ratio was tangent. But tangent of a circle, and there's a reason why they have the same name, is not the ratio, but it's a line. Okay, in a plane of a circle that intersects the. Let me show you the picture. Here's the tangent. You see this line AP? That's a tangent. So what do you think they're gonna say? A tangent is a line in a plane of a circle that intersects the circle. What? How? Yes. Without going into it? Well, does that mean it could be outside a circle? Would that be a tangent of a circle? In other words, does it have to then intersect a circle? What if it does not intersect a circle? Would that be a tangent? No. So guess what? Guess anybody? Yes. What do you think, Josephine? Circumference of circle? And actually, yes. Yeah, 1 point. Okay. It has to intersect the circle at exactly 1 point. If it did intersect in 2 points, guess what that's called? It's not a tangent anymore. Then it is a no. Look up, guys. Sine and cosine are the ratios of a right triangle. Secant, thank you, Emily. If the line hits the circle at more than one place, 2 places, right, then it's called a secant. If it only intersects at exactly 1 point, then it's called a tangent. And later you'll see why it's called a tangent. It has to actually do with that ratio of tangent. Opposite of adjacent. Remember what tangent is? Also another name for tangent was what? Yeah, slope. So actually, anyway. And this point A, you see this point. Okay, imagine that A is the only point this line hits. Okay, it looks like it's sort of hitting it more than one point, but it's not. Okay, so that line, I mean that point A is called point of tangency, and it makes sense why it's called point of tangency because, right, AP is a tangent and the A is the point of tangency for this tangent line. Okay. Does this make sense? So when we just say tangent, we mean a line, but we could talk about tangent as a ray or segment. So tangent ray will be PA, and tangent segment will be segment PA. So we could talk about tangent ray PA that way. Okay. In both cases, right, it does hit the line. I mean, it does hit the circle exactly at one point, at a point of tangency. So when we just say tangent, we normally mean line, but we could actually talk about tangent ray or tangent segment. So if the tangent went inside the circle, guess what? It must hit the circle in two places, correct? Right? Because if it, imagine, can a tangent, okay, let's talk about tangent in terms of tangent line. Because some people may say, oh, what about tangent ray? I mean, tangent segment. Okay, so a tangent ray and segment are part of this tangent line, okay? So anyway, so you must have a tangent line first, and within this tangent line, you could then get a tangent ray or tangent segment. Okay? So if the line went in, right, then it must hit the circle in two places, correct? It can't stop within the middle of the circle because, right, tangent ray or segment are from the tangent line. And by the definition of tangent line, it only has to hit the circle exactly at once. Here's what I mean. I think that's a good question. So, so like, let's say I have a circle, right? And here's a segment. Is this a tangent segment? I'm sorry. Is this a tangent segment? Is that what you're referring to? Yeah, so this will not be a tangent segment. In order to have a tangent segment or tangent ray, you must have a tangent line first, start with. And from that line, you could then get a tangent ray or segment. Okay, so this will not be a tangent, right? Even though this segment hits the circle only at one place. Does that make sense? That's a good point. Any other question? Okay, yes? Oh, because, so here's a nice, whenever you see a ray or segment, if you want to know whether it's a tangent or not, just extend this into a line. And if this line hits the circle more than one place, in other words, if it hits it twice, then it's not a tangent. Right, so even if it's a ray or segment, just extend in both directions. In order for it to be a tangent line or segment, the line that contains the ray or the tangent segment must hit the circle only at one place. Does that make sense? So yeah, that's why this will not be a tangent ray or segment. Okay, so that's one nice way to test it, right? Just extend it in both directions. It still has to hit the circle only once in order to be a tangent line or tangent ray. Okay. Good. So here is 3 ways to describe this picture. You could say AP, line AP is a tangent to circle O. You could also say circle O is a tangent to line AP. So it kind of works both ways like that. And you could also say A is the point of tangency. So it describes all these 3 statements describe this picture on the right. Okay. Any questions there? Are we good? Okay. And notice what it says here. Tangent rays and tangent segments are often called tangents. Sometimes they just call them tangents as well. And that makes sense because if you were to extend them, you get a tangent, right? Okay. All right. Then next, we're going to talk about sphere. Anybody want to guess how they're going to define sphere? Right? A sphere is what? Sphere with center O. And the radius of R is what? How about, okay, Joshua, what do you think? We sort of talked about this in the beginning, but how do you think we're going to do? Exactly right. And it doesn't tell you anything about, plane, right? So yeah, they actually say set of all points in space. They even say that in space at a distance r from point O. Okay. So that's the definition of sphere as we expected. And kind of thankfully, many of the terms used with spheres are the same with, anybody want to guess? Circles. This is exactly right. Okay. So here's a picture of a sphere. Let me move this up for you. Okay, hold on. Here you go. So there's a picture, and so I bet a lot of you can guess Somebody give me radii of this sphere. How about, let me call somebody at random. How about Jason? What do you think? Can you give me one radius? OA. Would that work, guys? Yeah, there you go. OA. There are, I think, two other in this picture. How about Brandon? You're here. Can you give me another one? Instead of OA, you could also give me. Yeah, so what would the radius of this sphere? So Jason said it was OA right here. Do you see any other? DO will also work. Good. All right, how about Krista? Can you give me the third one? OB, sure. Does that make sense? So those will be the radii, okay, of the sphere. All right, somebody give me the diameter of the sphere. How about, what would the diameter of the sphere be? How about Shanna? Uh-huh. Which one? dB, good. Okay, so there's the diameter. All right. So with this given points, right? I mean, I'm sure. How many diameters could you draw in this sphere? Infinitely many, but with the given points, right? dB will be the one. Okay. How about Joshua? How about? Can you give me over here? Can you give me the core in this sphere? CB. How many people agree? Can you just say CV though?
Segment CV.
Would it be segment CV? How many people agree with Joshua here? Segment CV. Anybody think it's something else?
Oh, I know
Is it a line CV or segment CV?
Oh.
It is segment, remember? Yeah, segment. He's right. Okay. So, but if I ask for
it.
secant, what would that be? The other Joshua. What do you think? Line CB would be correct. Does that make sense? Right? Remember the difference between chord and secant? Right? They both have to hit the, for a circle, it has to hit the circle twice. Same for sphere, it has to intersect the sphere twice. But for chord, it is a line segment, right? Endpoints are on the sphere. For secant, it's going to be a line. Okay. All right, then what else do we have? Here is tangent. Who can tell me a tangent of this sphere? How about Youngwoo? What do you think? Say it again. AT. And when we say tangent, is it a line or is it a segment or is it a ray? Line. If you say tangent, we just mean line. But what if I ask you for tangent segment of this sphere? What would that be? How about David? Yeah, of the sphere. AT will be the tangent segment, right? Segment AT. Would you not agree? Right, guys? Because doesn't that hit the sphere only once? Could it be OB? Can OB, the segment OB, the tangent segment, it hits the sphere only once? No, but if you're to extend it, is it a tangent? No, it would not be a tangent, right? It's a secant, wouldn't it? Does that make sense? So remember, be careful. Can CB be a tangent? Yeah, it's already hitting it twice. It can't be, right? What about OA? Can OA be a tangent? No. Even though OA, the segment, hits the sphere only once, but if you were to extend it, is that a tangent?
Yes. I mean,
It's not. Okay, so, right? Tangents, segments, array must, if you were to extend it, must be a tangent, right? That's what some of you were asking before. Does that make sense? So only tangent segment that you see here is AT. Segment AT. Are we okay? So tangent segment or array must be a part of a tangent line. Does that make sense? It must be a part of tangent line. Okay? And of course it has to have that point intersecting it. Alright. Here we go. So I bet a lot of you can tell me what congruent circles or spheres are. Okay? Congruent circles or spheres are circles or spheres that have same. Who could tell me? How about, because we talk about congruent. Madison, any guess? What do you think? They have the same. So what is that called? If two circles are congruent, guess what? They must have the same radius. This is exactly right. Okay. So for congruent circles or congruent spheres, they have this congruent radii. Does that make sense? Right? Right, guys? It's kind of like congruent triangles and so forth. Circles and spheres are kind of only thing you could really measure is the radii, right? So for congruent circles or congruent spheres, they have congruent radii. Okay. All right. Then what do you think? Okay. I'll wait. So that's a good point. A circle and a sphere cannot be congruent, right? Either two circles are congruent or two spheres are congruent. All right. What about then this? Anybody want to tell me? Anybody know what concentric circles are? What do you think we mean by concentric circles? One person? Think they know? All right, Josh, go ahead. What do you think? Circles with same center is correct. These are circles that lie in the same plane. So we kind of have to, right, make a distinction between circles and spheres. So you see how they talk about planes here? These are circles that lie in the same plane and have the same center. And here's the illustration here. These, yeah, this target, the circles, right? The rings of this target are the concentric circles. Okay. If you could have concentric circles, guess what we could also have? Concentric spheres. Okay. Triangles. Okay. Narek, what do you think concentric spheres are? These are spheres that
lie in the same plane. They have the same center.
they have the same center. They're not going to be in the same plane, are they? Because spheres are three-dimensional thing. Yeah. So these are the spheres that have the same center. You guessed it right. Okay. So go ahead and write it down.
Concentric spheres. But
Okay.
they look like the Earth.
All right. What do you think we mean by a polygon which is inscribed in a circle will look like? Okay. A polygon is inscribed in a circle. What do you think that represents? How about Jonathan? Any idea?
Polygon within a circle.
Yeah, polygon within a circle. How so?
It's like in the same plane.
Okay. Okay. So it sounds polygon is inscribed, sort of in a circle, right? It turns out it has to be in a particular way. You want to guess? Yes. Yeah, all the vertices of the polygon must hit the circle. Exactly right. What do you think this means then? A circle is circumscribed about a polygon. What do you think that means? A circle is circumscribed about the polygon. Hannah, what do you think? Hmm? Again, polygon is inside a circle again, right? And guess what? Both of these mean the same thing. It's this picture. It's describing this picture, right? So here's the definition. This is how they define it. When each vertex of the polygon what lies on the circle. Okay, so both of these statements represent the same exact picture. A polygon is inscribed in a circle. You see how the red polygon, right, this quadrilateral is in this circle, but not any sort of way, but in particular way where each of the vertices, right, all the vertices are each vertex is on the circle. Okay, or I could say the circle is circumscribed about the polygon. You can kind of think about a circle being going around this polygon, okay? Hitting each vertex of the polygon. Does that make sense? Are you okay? Does the polygon has to be a quadrilateral every time? Could it be a triangle or any polygons you want? Here's another picture that describes if the polygon is inscribed in a circle and a circle is circumscribed about the polygon. Is that okay? There's actually a short way of saying polygon is inscribed in a circle. The way to say that is they say something like this: inscribed polygons. Is that okay? So another way, shorter way of saying a polygon is inscribed in a circle, you say inscribed polygon. Okay? So these red polygons, right, are called, you could say, you see how these are red? They're inscribed polygons. Also, if I'm talking about the circle, you could also say, another way of saying circle is circumscribed about the polygon. Shorter way of saying that is circumscribed circles. You see how this is black? You see the black circles? Those circles are circumscribed circles. Does that make sense? So that's why they did it in red and black like that. And the shorter way of saying inscribed, polygon is inscribed in a circle. which is the same as inscribed polygons. Another way of saying circle is circumscribe about the polygon. Another way of saying that is circumscribe circles. Is that okay? Does that make sense? All right. Any questions? That's the last thing. That's last terms you need to know about the circles for today. Are we good? All right, good.